Okay, today we're doing Precalc APEX Semester 2 for finishing 4.1 and doing 4.2. So yesterday we started talking about proofs and we talked about the Pythagorean identities. Today we are going to talk about some more identities that we will be using to prove and to so the first ones that we're going to look at are the sum and difference identities. So these sum and difference identities are just what they sound like. So if you have sine of the sum of angles, then you can rewrite it using this formula. Okay? Sine of the difference of two angles, cosine of the sum, cosine of the difference, and tangent of both. Okay? So these are just formulas. For A and B are angle measures, either in radians or in degrees, and these are formulas, so we're going to plug stuff in. Okay. So to solve one of these, it says find the exact value of cosine of 75. So yes, we could plug this into our calculator and find an answer, but we don't want to do that. We are starting to deal in exact values. So for this one, to find cosine of 75. Thinking about our unit circle, we do not know any angle measures or the value of x for the angle that is 75 degrees. So look at the unit circle, we need to find angles that add up to subtract to equal 75. So those would be our 30, 45, 60, 90s, okay? The ones that are on our circle. So to get 75, I'm just going to say I can add cosine of 45 plus 30. So 45 plus 30 is 75. And these are both values we know from our unit circle. So then I'm going to go further and I'm going to say, okay, well, I know that it's cosine and I'm using plus. So I'm going to plug those values into this formula right here. Okay, so that's going to be cosine of A, which is 45, times cosine of B, which is 30, minus sine of A, which is 45, sine of B, which is 30. Now I know what cosine of 45 is. I know what cosine of 30 is. I know what sine of 45 is and sine of 30. So now I can plug it in and I can get the value. Okay, so cosine of 45 is square roots of 2 over 2. Cosine of 30 is square roots of 3 over 2. Minus, okay, there's that minus sign. Sine of 45 is square roots of 2 over 2. And sine of 30 is 1/2. So now we're just going to simplify. We're multiplying straight across. Square roots of 2 over 2 times square roots of 3 over 2 is square roots of 6 over 2 minus square roots of 2 over 2 times 1/2 is square roots of 2 over 2. And now I'm going to simplify it just a little bit further. It shouldn't be over anymore. 2 times 2 is 4. I'm not adding and subtracting those, I'm multiplying them. So now I'm going to simplify it just a little bit more, and these have the same value. I can combine them. So it's going to be square roots of 6 minus square root of 2 all over 4. Okay, and that's my final answer. That's as exact as I can get it. Okay? We do not want decimals. We want exact values. Okay, so now we're going to do the same thing, except now it's in radians. So it says find the exact value of pi over 12. So we really need to find two values that add or subtract to pi. We want to try, if possible, to stay in the first quadrant. So we want to make sure that these, we want to try, if we can, to make them positive numbers, and the smaller the better. It doesn't really matter, but you keep in mind that if you go into a different quadrant than quadrant 1, then you're going to have to make sure you put the right signs on these things. Okay, so to get pi, I could subtract 4 pi and 3 pi. But remember, I have to have that common denominator. Okay, so 4 pi minus 3 pi is pi, and when you're adding or subtracting fractions, that denominator stays the same. Okay, well, looking at this, I don't know the exact or an angle measure for pi over 12 or for 3 pi over 12, but we can simplify these. Okay, so this is 4 pi over 12 reduced over 3, 12 reduced pi over 4. Okay, so now that's what we're going to use. Okay, and we're going to go ahead and we're going to plug it into our sine of a minus b formula. Okay, so we're going to have sine pi over 3 times cosine of pi over 4. And then that's going to be minus, because that's what the formula says, cosine of pi over 3 times sine of pi over 4. Okay, so now let's just find what these values are. Okay, so sine of pi over 3 is square roots of 3 over 2. Cosine of pi over 4 is root 2. Minus cosine of pi over 3 is 1. And sine over 4 is root 2 over 2. Okay, so now let's go ahead and multiply. Square roots of 3 times square roots of 2 is square root of 6. 2 times 2 is 4. Minus 1 times square roots of 2 is square roots of 2 over 4. So this one just happens to look like the one before it. Because we're going to try and always use these values that we know from the unit circle, a lot of times you'll wind up with just, there's a couple of combinations that these can be. Otherwise, it just wouldn't work out. So because we're using the same type of angles, okay, the same 30, 60, 45, 90, okay, these are generally pretty close to the same thing. There's only a couple of combinations, which is why these just happen to come out to the same thing. Okay. So let's go on ahead and let's take a look at this next one. So this next one says find the exact value of sine of u plus v. So we're still using our sum and difference formulas. In this case, it's going to be a sum identity. Okay? And we're given that sine u equals 4 over 5, where 0 is less than u is less than pi over 2. Okay. So we're going to have to draw this triangle. Okay. So sine of u equals 4 over 5, and our triangle is somewhere in the quadrant between 0 and pi over 2, which means it's somewhere in this first quadrant. Okay, my sine is opposite over hypotenuse. And then it says in cosine of v equals negative 12 over 13. Now, a couple of things. If I try and put negative 12 over 13 here, well, these don't have the same hypotenuse. 5 and 13 are not the same number. So these are not going to be on that same triangle. The other thing we can see is that this triangle is somewhere between pi over 2 and pi. Okay, so we're dealing with two completely different triangles here. Okay, so this one is going to be negative 12 and 13. Okay, so we have to find those missing sides before we can do anything else with this. Okay, so let's go on ahead and let's solve for the missing side lengths. Okay, so here we can use the Pythagorean theorem and we can say that a squared plus 4 squared equals 25. Okay, so that's a squared plus 16 equals 25. And if you know your Pythagorean triples, okay, you automatically know that this is 3. Okay, so I'm going to go on ahead and say, okay, well, sine of u, we know, is 4 over 5. Okay, and essentially this is triangle u. Okay, so the cosine of u then would be 3 over 5. Okay, now we need to do the same thing here for our v. Okay, we already know cosine of v equals negative 12 over 13. Okay, and there's our 12, there's our 13. Okay, so we need to go on ahead and we need to solve. Okay, so I'm going to say a squared plus 144 equals 169. So that's plus b squared, which is 12, equals 13 squared. Okay, and then I get a squared equals 25. So a equals 5. So my sine of this v is going to be 5 over 13, and it's positive because this value is positive and my radius is positive. All right, so now I can start plugging this in. So now it's sine of u plus v. So sine of u plus v equals, and I use my sine of a plus b formula. So it's going to be sine of a cosine of v. Okay, so it's going to be sine of u, which we know is 4/5, cosine of v, which is negative 12 over 13, and then it's going to be plus cosine of u, which is 3/5, times sine of v, which is 5/13. So now I'm just going to do the math. So 4 times negative 12 is negative 48. 5 times 13 is 65. And then I'm going to do plus 3 times 5 is 15, and 5 times 13 is 65. So I'm going to wind up with negative 33/65. And that's my exact value. So if you see something like this, right, you need to make sure that you draw those two individual triangles. Okay, so this next one says to prove the cofunction identity. Okay, so our cofunction identity is one that just says that the cosine of pi over 2 minus x equals the sine of whatever that x was. So essentially, they're complementary angles, is what we're saying. Okay? So we're going to prove this using these sum and difference identities. Okay? So cosine of pi over 2, so this is going to be my a and this is going to be my b. Okay, so I'm doing cosine of a minus b. So I have cosine of pi over 2 times cosine of x. Remember, you don't need that negative sign in there. That's just telling us which formula to use. Okay, plus, now we're going to do sine of pi over 2 times sine of x. Okay, so cosine of pi over 2 is 0. So we have 0 times cosine of x plus sine of pi over 2, which is 1, times sine of x. Well, 0 times cosine of x is 0. So we're left with just 1 times sine of x, which is just sine of x, which is what we were trying to get there. So if you have an x or a theta or beta or alpha or whatever in here in an actual angle measure, then you're going to wind up with some theta or beta or alpha or x in your final, okay? Unless everything cancels to zeros, which doesn't happen often. So keep that in mind as you're working these. Now let's go ahead and do this next one. So it's cosine of theta minus 3 pi over 2. Okay, so we're going to use our difference identity for cosine. So we're going to wind up with cosine of A times cosine of B, and remember we don't need that negative sign, that's just telling us which one to use, plus sine of A times sine of B. Okay. Alright, so cosine of theta is going to stay cosine of theta. Cosine of 3 pi over 2, okay, so that's at the bottom of my unit circle here. Okay, so that's going to be 0, negative 1. Okay. Alright, so cosine of 3 pi over 2 is 0. Plus sine of theta, and then sine of 3 pi over 2 is negative 1. Okay, cosine of theta times 0 is 0, and I'm left with negative sine of theta. Okay, go on ahead and try this next one on your own, and then we'll take a look at it together. Pause the video, try it on your own. Alright, hopefully you tried this one on your own. So this is tangent of an A plus a B. Okay, so we're going to go on ahead and plug this into our sum identity for tangent, which says tangent of theta plus tangent of pi over 1 minus tangent of theta times tangent of 3 pi. Alright, so tangent of theta is just going to stay tangent of theta. Okay, but tangent of 3 pi, well, let's look at 3 pi. This is 0, pi, 2 pi, 3 pi. Okay, so this is going to be negative 1, 0, so our tangent here is 0, okay, because it's our sine over our cosine. So times 0. And then we're going to have 1, oh, that's plus 0, see? Gotta pay attention, plus 0 on the top. So here we're going to have 1 minus, now this tangent of theta times 0, that makes that 0 as well. So now we're going to wind up with tangent of theta over 1, or just tangent of theta. Okay, so the next one that we have are some double angle identities. Okay, so this right here is just if you have the sine of 2 times an angle, we can rewrite it. Same thing, cosine of 2 times an angle and tangent of 2 times an angle. Now keep in mind that this is 2 times the sine of an angle, whereas this is sine of 2 times the angle. They are 2 totally different things. And knowing that, I was copying and pasting and copied that wrong. So that should be 2 cosine of x plus sine 2x equals 0. So we're going to actually solve this and find all of our solutions for this. Alright, so what we're going to do is we're going to go on ahead and we're going to start by solving this. So I'm going to go on ahead and rewrite sine 2x as 2 sine x cosine x. So I have 2 cosine of x plus 2 sine x cosine x equals 0. And we're actually solving this. We're not verifying, we're not doing a proof, we're finding some values for this. Okay, we want to find what values can x equal. Okay. So now, notice that I have a 2 cosine here and I have a 2 cosine of x there. So I can actually factor that out. So I'm going to wind up with 2 cosine of x times, well, 2 cosine of x divided by 2 cosine of x is 1, and 2 sine of x cosine of x, oops, sorry, my hand's in the way, 2 sine of x cosine of x divided by 2 cosine of x leaves us with just a sine of x. Okay. So think about your quadratics now. Anytime we're solving quadratics, our steps are to factor and then set each of our factors equal to 0 and solve. We're going to do the exact same thing here. So now I factored, I'm going to set each of my factors equal to 0 and I'm going to solve them each individually. Okay. So now I'm going to divide both sides by 2 and I get cosine of x equals 0. Okay. And here I'm going to subtract 1 from both sides and I get sine of x equals negative 1. So now, where does my cosine value equal 0? It equals 0 at pi over 2, and every time it hits that spot again, and it equals 0 at 3 pi over 2, and every time it hits that spot again. So don't forget that 2 pi in if it says find all solutions and doesn't give you a domain. Same thing here. Where is our sine equal negative 1? Well, that's only at 3 pi over 2, but also every time it repeats around that circle. Now notice I've got it there twice. I don't have to include it in my answer twice because it's already there. It's okay if you leave it, but if I've already got it once, it's not going to make a difference which one I choose. Okay? It means the same thing. So we have just a couple more things to do for 4.2. Okay. So this is our power reducing formula. So all this does is it makes it go from a squared, okay, a power, an exponent, to being non-exponential. Okay. And then we have our product to sum identity. So what this does is it makes it go from a product to the sum. Okay? So it goes from multiplication to addition or subtraction. Okay? And we're going to use these to solve some stuff. Alright, so let's take a look at this one. So this one, also same thing. I'm copying and pasting, and I did a bad job, put some wrong ones in here. So that should be sine 2 of x. Okay? We did one similar to this the other day, but now we're actually going to take it a step further. Okay, so let's do work one side. So we're going to do sine of x plus cosine of x squared, which means sine of x plus cosine of x times x plus cosine of x. So I have sine squared x plus our FOILing. Okay, then I'm going to do my outer, so plus sine x cosine x. Then I'm going to do my inner, so plus cosine x sine x. And then I'm going to do my last, which is my cosine squared x. Alright, the first thing I see is I see a sine squared x plus a cosine squared x. That is equal to 1. That's one of our Pythagorean identities. The next thing I see here is that I have a sine x cosine x plus a cosine x sine of x. Now, those multiplications, it doesn't matter if sine or cosine comes first. So I'm just going to say there's 2 sine x's times cosine x's. Well, it looks almost like this, okay, except we know that this right here is the same thing as sine x because it's one of our double angle identities. So now we're going to have 1 plus sine 2x, which is what we were going for. Remember, I told you that at the beginning. And then this last one, we're not going to work this one. It's doable, but it's pretty difficult, and I would rather spend the time going over proofs more. So we're just going to cross that one out for today. Do the 4.2 worksheet, and we will finish 0.3 tomorrow. Practice problems. Have a great day.